a bit. So now we're going to really dissect the periodic table. Let's see how it's organized, what it's divided up into, how we can get different pieces of information from it, such as the group, families, chemical reactivity. So already we've learned about valence electrons, and what we're going to learn now is the organization of the periodic table. But before we do, let's look at the gentleman who actually created this organization that we are now familiar with. So Dmitri Mendeleev there we go. Dmitri Mendeleev, he's the main contributor to the periodic table that we now know today. He started us on that journey. He actually listed the elements in vertical columns according to their masses and predicted the properties of the elements not yet discovered. He used what's called the octet rule. So if you remember, we talked about the noble gases have 8 valence electrons. That's the octet rule. So he saw repeating patterns in that. Then Henry Moseley came along and realized after the proton was found that this organization of atomic mass was not the best organization for the periodic table, and he organized the periodic table into what we know today, which is by atomic number. So Mendeleev is credited with coming up with the first periodic table, and then Moseley is credited with coming up with the periodic table that we're familiar with today, which is organized by atomic numbers. So let's talk about the organization of this periodic table. If you look, this nice dark line that looks a little bit like a staircase actually divides the periodic table into our first 2 groups. You've got the group of nonmetals and metals. The nonmetals are to the right of the staircase and the metals are to the left of the staircase. And how do we categorize something as a metal or a nonmetal? If you look, the metals are actually the biggest group on the periodic table, and they have very specific characteristics. So let's see what they are. So for metallic properties, they are things such as high luster. And if you think about that word luster, you already know that we tend to talk about metals as being very shiny. They reflect light. So when you think about copper and nickel, we tend to think of nice shiny metals. The other thing about metals is that they're this word malleable, bendable. If you think about jewelry and things like that, we tend to be able to bend them into all kinds of intricate pieces. So that's another property of a metal. Metals also conduct electricity, but besides electricity, they also conduct heat. Wow, that's not writing very well. So think of a pot on a stove, and when you have a pot on a stove and you go to grab that pot, remember the heat source is coming from the bottom. But even if you grab the metal handle or the side of the pot, it's going to be very hot, and that's part of the metallic property that metals can conduct heat or electricity. That heat or electricity goes throughout that metal. Metals also tend to react with acids. They will react very well, and one of the ways jewelers can determine if a jewelry piece such as silver or gold is pure is actually by taking an acid and reacting it with it. Metals form positive ions. This is actually what we've been talking about. So if you remember, some metals such as sodium, sodium's outer electron is an S1. And so what ends up happening is because we talked about that octet rule wanting 8 outer electrons, sodium can either pick up 7 or lose 1. It tends to want to lose that 1, and it becomes Na+. So now you know that all metals will form positive ions. All metals lose electrons. And the last property of metals is that they're ductile. They like to be, or they can be, drawn into a wire. Think of your copper wiring, your different wiring that goes on throughout the house. Now, the non-metallic properties are the opposite of the metallic properties. So as long as you have one of these memorized, you know the other. So if metals are shiny, nonmetals are dull. If metals are bendable, nonmetals are brittle. If metals are conducting electricity and heat, nonmetals are non-conducting. If metals form positive ions, nonmetals form negative ions. So looking at a nonmetal forming a negative ion, we might think of something like fluorine. So fluorine's outer shell is an S2 and a P5. Wow, this is not writing. And a P5. So if you look, fluorine has 7 valence electrons. So because it has 7, it would rather pick up 1. So fluorine will become a -1. So good news for you is all nonmetals form negative. Okay, so that's the biggest division of the periodic table. Now let's look at some smaller groups or families. So we categorize a group or family as a column on the periodic table. These are groups or families. And there's only a couple that you need to know. The first one is on the metal side. So this first group or family is the most reactive metals. They are called the alkali metals. And the alkali metals are group 1. Notice hydrogen is not an alkali metal. We'll talk about hydrogen a little later. So the alkali metals, they're extremely reactive. They are so reactive that they will actually react with water. So one of the things you want to make sure you do is ask me tomorrow, the next class period I see you, to do that reaction of your alkali metals with water. I actually have lithium, sodium, and potassium that we can look at, and it's a great little reaction. The other thing is because they're so reactive with water, if you think water's in the air, water's in our hands, we actually store them in kerosene or oil because you've learned already that oil and water don't mix. Because of the fact that they're so reactive, they don't exist pure in nature. They typically exist as compounds. So you already know a couple compounds. You know that you have sodium chloride. Wow, this is not writing. Sodium chloride, lithium chloride, lithium fluoride. These are just a couple different examples. They are all silvery and soft. They can easily be cut with a knife, and I will show you this when we do the reaction. And then just a couple key elements and some things about them. So sodium and potassium are important in our bodies. They're not necessarily vitamins, they're minerals. Cesium and francium, which again you're going to see, are very reactive. So let's go back and look at the next group of metals. So the next group of metals on the periodic table are actually right next to the alkali metals, and those metals are the alkaline earth metals. Now, the good news is the alkaline metals are the most reactive metals. These are the second most reactive, so their reactivities are a little less. So they are actually less reactive than the alkali metals. They have a slight reaction with water, but then the main thing about them is the interesting different elements that are in the column. So beryllium is found in emeralds. So for those of you that like emeralds, it's that beryllium that gives them the beautiful green, plus a few other elements in there. Magnesium, if you remember at the beginning of the year, we did that great little demo where we took some magnesium, put it in fire, and it made that bright white light. Well, they tend to use it a lot in lightweight aircrafts because it's so nice and light. And then, of course, you know, calcium's in our bones and teeth. But did you know that it's also found in limestone and marble and seashells? Strontium, if you remember strontium, that bright red, we tend to use it in road flares and fireworks. And then radium is found in uranium oil. All right, so going over now, those are the two important groups in the metal side. We'll talk about the middle group next. The big group in the nonmetals are the halogens, which are fluorine, chlorine, bromine, iodine, and astatine. So these are your halogens. They are the most reactive nonmetal group. And just a little key things about some halogens. The name comes from Greek meaning salt former. So again, NaCl, if you think of that, KCl, NaF. Anytime you take a halogen and combine it, we tend to call that a salt. They're very reactive with alkali metals. We tend to see a lot of compounds formed with alkali metals and halogens. Primarily, we use them in bleaches, water purification systems, insecticides. So just a couple other things. Fluorine is a gas. It's colorless. Chlorine is also a gas. If you look at your periodic table, all the elements in red are gases. Bromine is a brown liquid. There's actually only 2 elements on the periodic table that are liquids at room temperature, and bromine is one of them. And then iodine is a gray-silver solid at room temperature. Now, some other things you might be asking, hey, what about something like boron? What would we call that group? Well, if you look at boron, come on, slide, you can do it. There we go. There are some old names that are out there, such as chalcogens. This is the oxygen family, but we don't use that name anymore. We typically, for the carbon, nitrogen, boron families, we call them according to the first element at the top. So that's the name we'll give to those groups or families. So I'm calling the groups or families the columns on the periodic table. So the columns on the periodic table are the groups or families. The rows that go across are what we call periods or series. So this is where I'm going to end the first part of the periodic table, and then the next day you're going to hear the second part. So now what you need to do is go and take the KIA quiz to see what you've picked up. So good luck.